All right, so you guys should already have a foundation for this lesson on comparing objects versus comparing primitives, but I'm still going to go into it in detail just to make sure that we have a real concrete understanding, because this is a pivotal part of the AP exam. So let's talk about comparing objects. So when comparing primitive types, if you recall, we can do something simple, right? We can say, if we have an integer x, we could do something like this. We could say if x double equals y, then we can do some code, right? And this is fine as long as these are primitives. Primitives. As long as these are primitives, this works fine. Primitives, remember, for our purposes, are going to be doubles, integers, and booleans. And of course, booleans are their own thing, but really doubles and integers are what we care about. Things are different when we have objects. Recall also that an object is really a reference. Objects are references. So when I say something like this, when I say dog Fido equals new dog, what's really happening here is I'm creating a new reference to a dog class that is called Fido. So I'm doing this in memory. I'm creating a little box, Fido, and this little box holds that memory location that then references my dog, right? And this is my specific dog with the information for Fido. So Fido is really just holding that memory address that points to and references the dog that I have just created. But Fido himself is just a memory location. So he's just a memory location. Memory, right? Memory location. So he's just a memory location. Now, if I create another dog, not dig, dog. If I create another dog, and let's call him Pluto. If I create another dog, Pluto, and I set my other dog, new dog, he is now also a new memory location that points to a different dog. And even though they're of the same type, they are two different dogs. Now, they might store the same information. I haven't passed in any parameters inside of here. So they store the same type of information inside both of them. So if I do this, if I call an if Fido equals Pluto, I'm going to get back, and this is going to evaluate to false, even if the information inside both of them is the same, because they are two separate, these are two separate boxes, two separate dogs stored in memory. So how do we get around this? Well, the way that we can get around this is using the built-in .equals method. Now, every single object in Java comes with a .equals method. Some of those .equals methods for things like strings and most of the objects that we're going to use in this class actually check the contents of the object and not just the memory location itself. So to get around this problem of checking whether or not Fido equals Pluto, is I would say this: if Fido dot equals Pluto, now it's going to look at the actual contents of these two boxes. And since both of them have a dog, and in this case we haven't given those dogs any information, the information in them is going to be exactly the same because it's the default dog. So we have our default dogs, and this would evaluate to true. So this would evaluate to true because it's now checking the contents of the box. It's going into the box to look for the answers. And it's not just checking that the boxes are the same box. Now, if I did this, if I said on a new line, Fido gets the value of Pluto, what I've now done is I've taken that Pluto box and I've taken that memory location and I've copied it. Let's say, let's use red for copy here. I've taken this and I've copied it into my Fido box. So now, if I look at these two boxes separately, now my Fido box and my Pluto box are now both pointing to the exact same dog in memory. So now if I run my if Fido double equals Pluto, I am in fact going to get true. As well as if I say I'm going to have an S there, equals Pluto. So now both of these statements will evaluate to true. Because Fido and Pluto are pointing to the same object. They're referencing the same dog within memory. Now, this doesn't seem very useful, but it can be useful. And one of the ways that this can be useful is when we are creating alias objects that we haven't set to a value, but we've set to that fun keyword null, and we want to check to see if an object is actually null. So we can say this. So let's continue to use our Fido. So we have dog Fido, and let's say we declare dog Fido. And we set Fido, instead of equal to a new dog, we set Fido equal to null because we aren't sure what we're going to do with Fido yet. So we don't want to create a new dog in memory. Well, maybe later in our code, we need to do something with Fido, but we want to make sure that we have actually set Fido equal to something. So we could create a simple if statement that says if Fido is equal to null, right? Then we could say, well, now do something. Or we could, conversely, we could say if Fido is not equal to null. So if Fido actually has a value in it, then do something. Otherwise, skip it and move on. So this is where actually using these simple comparators is useful. Now, pitfall, warning. Okay, let's talk about a big warning here. One of the things that we have discussed are wrapper classes. And I talked about how Java automatically kind of figures out what you want to do with a wrapper class based on what it sees in the code. But one of the places that Java isn't sure of what you want to do is when we're doing relational operators within an if statement on wrapper classes. You may actually be trying to compare the memory location. You might be trying to compare the memory box of, say, an integer class, and you want to see if two variables are pointing to the same integer class. So Java doesn't auto-box and unbox. So Java does not auto-box and unbox for relational operators. Box or unbox. So if you have, I should do capital I like that, integer, if you have integer a equal to 3 and integer b equal to 3, and you have an if statement this will evaluate to false because these are two separate boxes, right? So even though we have auto boxing happening here, right? This is auto boxing happening in these cases. We do not have auto boxing or auto unboxing happening in our third line here. So A is its own box, and B is its own box, and each of them points to a separate integer. And even though both of them store the value 3, they are separate boxes. And when it comes to comparing objects, these boxes are not equal. They are not equal because they're separate boxes. Not because of the value, but because of the boxes. Okay, that is a quick run through of comparing objects and a pitfall of using wrapper classes. I've seen a few of you in your assignments have been using wrapper classes just because it's a little bit easier or it's something you've gotten used to, but we want to use primitives whenever we know we're going to be doing comparisons like this so that we can avoid any of the issues caused by not auto-boxing and not auto-unboxing. Something to be careful of. See you guys in the next one.